Howdy guys, this is Zodin or Toaster here, whichever you want to call me. So this is my first video series, which is pretty funny because you'd think that I would pick something that I'm a little bit more literate in. However, I'm definitely not going to say I'm not qualified to make a video about cryptography and steganography. I actually have a pretty good amount of first-hand experience with it, only in a utilitarian sense. Like, I guess, I never had like a real scholarly interest in steganography or cryptography in the same way that I do other, other aspects of computing. However, it was one of the first ones that I really had to learn because I needed, rather than learn because I wanted. That makes sense. However, recently, I've started to delve a little bit deeper into, it's definitely what I would call a rabbit hole. And everything really is, especially when you're doing any form of, programming, because there's just so much and there's always changing so fast. But cryptography is the one that probably evolves, I guess. I don't want to say the most or the quickest, but because I'm not really like, I know what I know. I know how to use cryptography for my purposes, and how to do so effectively. I know why it works, at least on like a core level. So don't take anything I'm saying as like, I guess, a professional said it, or somebody with like the credentials or the experience. I'm sure somebody's going to watch this video and they're going to point out plenty of things that are wrong that I'm saying, and I really encourage you to do that, because it's not about who's right, it's about what's right. So, I don't want to be giving out any misinformation. And that's not really a concern normally. I usually try to be pretty spot on about my sources and about the things that I claim to be, empirical fact. But I guess specifically with cryptography, you got to really be careful, because there's a lot at stake for when you're actually applying this shit. I know that's the only reason I ever, became familiar with it. Anyways, let's just get on to fucking coding. I don't know if it's been mentioned on my channel, but I specialize, or pretty much all I do is Python. Judge me as you will. I tried learning C++, I tried learning JavaScript and PHP, and they didn't really stick with me in the same way that Python does, because, well, for instance, here I am making, a video about something I'm not that, I don't have that much of an expertise in. And that's what's cool about Python, is that you really can get started, with, a completely alien, framework or territory, within minutes, and, do so effectively, and actually, I think it accelerates the process of actually coming to understand these concepts that you're working with, and that's why I like it, because it's a high level language. So any informative or demonstration videos I might make will definitely all be using Python, just because you can really do anything with it, and I think it's a good way to just sort of abstract these concepts into things that we could work with mentally. But actually, before we actually start working with any code, though, I'm gonna do a little bit of theory here. So basically, cryptography is I don't know, what is cryptography? Cryptography is encoding something, or using a cipher to obscure what normally would have been sensitive and accessible, or what's the word? Comprehensible, human readable data. Cryptography's been around for, since, I don't know. I don't have like the facts right now. I'm on Wikipedia, but I do know that they did use ciphers in the Roman Empire. I don't know what time. If somebody could look that up for me, that'd be cool. But cryptography's really evolved because the idea is that, well, in most cases, I guess in the classical use case of a cipher, we want to effectively protect something sensitive from, unwelcome eyes, anybody that might, get a hold of it. But we also want it to be easily, what's the word? Decrypted. That's the word, decrypted, but, there's a better word. Unwrapped is how I feel. It's kind of how I imagine cryptography is. You're basically just, like, tangling it up in a way that nobody could ever untangle it, but if you have, like, the key or the WD-40 or whatever, it'll untangle. So that's basically, the premise of cryptography is, I guess in the first early implementations historically, we had, they had a cipher, which would be like, it could be a key or a code, or not code, I guess, an alphabet, or something, something that you could easily reference and, effortlessly, make this completely nonsensical data human readable again, or, back into its original form. And, hopefully the idea was, the goal was that the recipient of said data, or the intended viewer of the data, would be the only one to have the key or the cipher. And obviously there's some like loopholes with that, and that's not even like addressing the fact that there's never a perfect encryption, what's the word, form of encryption, or hashing or whatever, cipher. People will always figure out how to eventually basically decrypt it without having the authenticated tools to do so, or sorry, I lost myself there. So we'll start with the basics here, though. So what actually is encryption, I guess, in its modern context when using computers? Well, I think that the best way to understand encryption is to take a look at how websites or anything that takes a password authenticates and stores your password, because obviously your computer just can't just have like a text file sitting somewhere with your password in it. That would be stupid. Neither can a website, although they do still used to a lot more. But the problem is, though, is that, well, if we can't do that, then how does the system or the authentication engine, how does it actually confirm that the password or the passphrase you gave is the one that is the correct one? Well, we have something called hashing, and you probably already know what hashing is if you're watching this video, but I feel like you just gotta start there. Let me go ahead and open up the terminal here. Oh, too much time to make this maximum. Sorry, I want everybody to be able to see this. So before I actually get into the Python code, we can actually use the command line utilities that Linux, I'm pretty sure Unix, most Unix systems, I'm not sure, they provide these for basically on the fly generating a hash of, it could be binary data, it could be a string of text, Unicode. It can be a file, which, all of these things are the same. It's either binary data or it's Unicode, which is some binary. Basically, we're just using very, very complex mathematical algorithms, and see, that's where I'd get lost, actually. I don't understand anything about the math of it. I just understand the workflow of it. Basically, do a bunch of math to it that you can't undo. So it's not like algebra where you can go the other way and solve for x. It's like, no, that's it. If you hash it and you lose the original, you just have the hash. Now there are some exceptions, but that is like, in principle, in theory, that is the way it's supposed to work. But obviously, people crack hashes. So if you actually type in SHA, do a little tab right there to autocomplete, you'll see SHA. I forgot what SHA stands for. See, I should have done my studying for this, but I really just wanted to make a video. Anyways, basically these are the currently available hashing algorithms for, now this isn't encryption, this is just hashing. However, it is the same concept. So for example, say I have a file called whatever.text. In it, there are some things and some secrets. Cool. So we have a file. In it, there are some things and some secrets. Now, the purpose, one of the main purposes of hashing, besides validating passwords, is to validate and verify that a file has not been tampered with or modified or, corrupted in any way. Basically making sure that, okay, this file that, we have here in the server or wherever, when we come back to it next time, it better say the same thing that it did last time we got the hash for it. And if there's anything different about it, at all, then it's going to generate a different hash. So hashes are unique, and that they're, if you can't fake it. Now, obviously, like everything with cryptography, there's some exceptions, but, and sorry I keep looking up and above. I have another monitor right here, my webcam's right here. I don't have a very good setup, but you probably don't look anyways. So what we can do is actually, let's go and try this. We'll just do SHA-1SUM, and we'll do whatever.text. And what it's going to do is it's going to return, look at that. Now, why exactly does it give you both the hash and the file name? That's for the purpose of checking it. So let's say I wanted to send this file to a friend, and we're sending it maybe through, we're not using HTTPS, we're worried about possible interference with our, our secure, sensitive file. So basically what you do is make sure that the recipient has a file, text file, that has that output that we just generated. And so that way they have the original hash of the file before it gets sent to them. Or, whatever your context is. So we'll do checksum text. Basically the same, do that same thing we just did, but instead of outputting it to the screen terminal, we're going to output it to a file called checksum.text. And now, so that way, there we go. So now we can send our friend that file. So let's say we send the friend the checksum. Cool, they have a checksum, and they get whatever.text. Okay, cool. Now before they do whatever it is with the file, it might be an exe, it might be trying to install, something very complex and easy to what's the word, exploit. So basically what they would do is SHA-1. They would do, instead of doing SHA-1SUM and then the file, they do check and then do checksum.text, ensuring that the file that it's going to check the hash for is in the same directory. Alright, and there you go. So basically, it just, that doesn't tell us much. However, let's fuck with the fucking file real quick. Let's, we're gonna echo some exploit and append it to whatever.text, so that way we're changing the file. It's still named whatever.text. Let's try that again. Failed. One computer checksum did not match. And so, there you go. Somebody screwed with your file. So this is really pretty far from encryption, obviously. But both of them are basically trying to protect something, whether that's from observation or from manipulation. And I guess that's where cybersecurity comes in, is whether you're protecting data or privacy or you know, your actual system, whatever, your tools, your components. This, you know, this is sort of like the what's the word? The foundation for, you know, all the science that is security. And so, by the way, let me just go ahead and say, don't ever use SHA-1 sum for anything that might be, you know, password like related. Because now, what we just did here, the same method, was using a hashing algorithm to check and verify a file, or generate a hash for a file. It's exactly what a website does for user authentication. When you register for a website, so let's go and do some Python code. This is to basically indicate that even though you provide your password to the form when you register to a website, it's supposed to be this way, but nobody, not even the person who wrote the code for the website, you know, or is running it, you know, looking at the logs, they will never know your actual password. And that's not because, you know, they care about knowing, you know, your privacy. It's mostly because they're responsible for it. If it gets, you know, if there's a breach to, you know, into their back-end server or their database, then, and, you know, these passwords are exposed, then they're responsible for that. So they do this mostly to save their own apps. But so basically, from the Python shell, we're going to import something called getPass. And basically, this is so that, say you have a Python application and you want to accept passwords in it, maybe. Well, instead of being like, you know, password equals string input. Basically, instead of saying, you know, this, we're, okay, we put in our password. See, the problem with that is we're having to expose it in clear text. You know, you want it to, sort of want there to be a ghost in the machine, I guess, when you're accepting passwords, especially input. You know, this is how we maintain security, you know, on a, like a base level. So, instead of doing that, we would say password equals getPass. So we're actually going to call a function from getPass is the module that is being used, and getPass.getPass is the actual function within that module, because there's some other ones like getUser and all that. Basically, what this does is, oh wait, watch. You don't see anything. That's crazy. But if we were to check, okay, what does the variable password have? Oh, look, it has what I typed in. So, this is how we can securely accept password inputs and then pass them on to, say, a hashing algorithm. So then, you know, our application might do something like this. This is the standard library for generating hashes, digests, basically, which is what you saw earlier, all the random data. So, if you go ahead and look at algorithms available, this is a nice little, well, a dictionary list. Yes, it's a list. Well, it's a dictionary, but of all the available algorithms, and you know, I could spend days going into all of these, and you know, I probably would if I actually knew enough to. All I do know is that we don't use SHA-1 for actual security purposes, or MD5 for that matter. I guess when it comes to actual security, we prefer SHA-256 and 512. Now again, if I'm wrong on any of this, please somebody correct me, put it in the comments, and I will make a response video. You know, can't let people think things are wrong. So basically, to do what we just did in the command line with, you know, we just generated a hash. It's a little different in Python because it's an object-oriented programming language, so we actually need to create a hash object. So say we have our password. That's our variable with our password in it. Now, if we wanted to store, you know, that password's hash, say in a web server's back, you know, database, for reference, for authentication, then we would do this within the same script, So first we'd say hasher equals hashlib, and we'll go ahead and do SHA-256. Oh shit. Now, we're also going to pass our password variable as an argument to this object. Oh wait, what? Oh, what? My bad. Ah, that's right. We can't just do this with a Unicode object, although I thought we could. So what we would do actually is encode, because it's just a string. Basically tell it to encode a Unicode to bytes. And that. Bite. Okay. So it was our little hasher object. Now we can now look at the actual methods available to this hasher object. Actually, that's too soon. So yeah, some of this is, I don't really use any of this actually, but like the side of the digest or hasher, I guess you can give it a name. I really fucked with that, and I'm not going to advise it unless somebody else has read the docs specifically for it. Okay, there. So if we call the method hasher.hexDigest, this returns the hexadecimal digest of that hash. Now, you can probably tell that there ain't no way in hell somebody's gonna sit here and be able to tell what that says. But say we wanted to authenticate our user. Let's go ahead and write a script for that actually. Let's get a nicer Python shell going, a little bit more interactive here. And this should probably conclude our video today. Oh shit. Not Python 2.7. Oh my. But yeah, this will probably conclude today's video because I've already gone on long enough and there's a lot more. However, hopefully. Anyway, we're going to import getPass, and then we're going to import hashlib. I don't think we do anything else. I always just import OS because sometimes I like to clear my terminal from the shell, and they're handy. So, we're going to say, let's define a function actually. Define set password. Oh shit. God, that's why. Okay. So first, our function is going to create a variable, and that variable is going to be the string, making sure the input's a string. It's going to take our input, just a normal input, asking for our username. And then, after that, no shit. Alright, cool. And then after that, it's going to get the password. So this is going to be for registration. This is not logging in, I guess, in our current context. So this is when you're actually creating the account. They don't know your hash. They don't have like a hash yet for your password. Never given it to them. Then it's going to securely get our password input. And then what it's going to do is going to hash equals hashlib dot SHA. Let's do SHA-512 this time because we already did SHA-256 and we'll do a little bit different. And now we got to make sure to encode, because our password is a string, we need to encode binary data. Alright, and then actually, we're going to make another variable, and that's going to actually be the hex digest of that hash object. Basically, the final readable hash. And then we're going to open up a new file, and then name it after this username that we gave it, and then store that password hash in there. That will be our function. So let's go ahead and do that. I'll do user. There we go. What you're seeing me do here with those brackets, curly braces, That allows us to format our text strings with variables, dynamic, whatever. Format user, I think, we want to say W because that means to open it in write mode instead of read as F. This whole with statement you're seeing, it's we could just say that, F is equal to, this open file that we're about to write in. However, there's a problem with that, and that people sometimes forget to close the file, or, say something crashes or whatever. There's an exception that gets raised before you get to close the file manually. Well, that's just not good practice, for garbage collection and shit. So then we just write password hash. So we're saying to that file object, we write the password hash, and that will. Cool. So we just defined the function, but now we have to actually call it. Actually, let's go ahead and just, if I can do the other one, we check password. More or less look the same, but we'll see. We'll say hash pass equals hash lib password code. Basically, we're basically doing the same thing that we just did in the other function. Will look a little different here. So I could have all done this in a one-liner too, but I don't want to do that for people who aren't very familiar with Python yet, because that'll just confuse you. And now we're going to say with open user, same thing as before. Format it to that username, but we're going to open it in R mode or read mode. Big difference. And then we're going to say or we'll say auth hash. It's not a very good variable name, but it's okay. f.read. So this will return a variable with the actual with the password hash of the correct password. And then we can say if password hash do a not equals to statement auth hash print error invalid password else print welcome. We'll do just format again. Alright, cool. Let's do set password. Let's actually see these bad boys in action. So I'm going to do my good old. Yeah, look me up on Twitter, why don't you? And see, I can actually use a real password because you guys can't see what I'm typing. See? Secure responsible programming. So in that instant, it created our file. We can actually check right here. Oh wait, no, we cannot. I don't know what anybody saw on that, but I promise it wasn't anything embarrassing. So now we check password. So we'll go ahead and try to log in. We'll say toaster key. We'll do it successfully first. Wait a minute. Really? Alright, let's try this again. I'm gonna just set it to something easy because I think I just got it wrong. Check. There we go. Alright, see. I actually just made the password that time, so there wouldn't be any chance I fucked it up. So there we go, logged in. And now you can see, you know, if we actually fucked it. So basically, we'll say, I mean, that's pretty much a wrap, guys. I think you guys get it. I mean, as far as this really didn't touch on cryptography, but I feel like it's once I came to actually, you know, because I started working with GPG and you know, PGP regularly before I really even understood hashing, and you know, nobody really realizes. I guess people that aren't very familiar with technology or on that level, you want to realize that hashing is kind of really important, and a lot of, you know, very, very, you know, important things rely on it. You know, we basically trust all of our personal data. You trust all of your financial info. You trust, you know, people trust their lives to the security provided by these, you know, the science, and it, you know, there's always, you know, a better way to be, you know, to use these tools, but it's pretty interesting just to see how they work in their rudimentary form, and it's pretty amazing, you know, to think that we, as humans, have figured out a way to actually fool ourselves, and we've outsmarted ourselves, you know, with cryptography. We're like, okay, now nobody knows what it is, but we have a way to get it back, and that'll be for the next video in our symmetrical encryption and decryption, which is, I guess, the classical form of cryptography. Anyways, appreciate you guys watching. Please like and subscribe, or at the very least, like, throw a rock at my window. If you notice anything, you know, that might have been misrepresented as far as facts go or information goes, please don't hesitate to comment and you know, correct me, and if need be, message me so that I actually get around to correcting it. Anyways, I will see you next time.